Okay, having a little deja vu. I feel like I did this problem yesterday, but I don't have a video of it, so I must be doing it again. Okay, let's do it. We've this is just happens to be the decimal version of uh, a regular type of problem. Now, you could do something with this if you want, and I could show you how to do it. Um, Not really necessary. Actually, I'm going to solve it first just straight away normally, and then I'm going to show you what you could do at the end just as an add-on. Okay, so plus 1.4. We're taking this away. Let's do that first. Take away that 1.4. So minus 1.4 equals 5.9 minus 1.4. Okay, so this goes away. That's the whole point of it, what we just did. So we've got 1.5x equals 5.9 minus 1.4. Do the calculation over on the side if you need to, but 5.9 minus 1.4, 4.5. I knew what that was. I just wanted to show you and do it off on the side, okay? So now we need to divide by that 1.5. And if you know anything about the multiples of 15, you know that multiples of 1.5, okay, relate to the multiples of 15. It's just a decimal in a different place. We get x equal 15 goes into 45 three times, so 1.5 goes into 4.5 three times as well. Now you can do that division over on the side if you want. I'll do a proof for it first, and then I will talk about my little other technique that you could do if you wanted to approach this from a different way. Okay, so proof. Sorry, that looks funny. I'm writing from, reaching from way below to do it. Now, let's see. 1.5x plus 1.4 equals 5.9. And then 1.5 parentheses 3 plus 1.4 equals 5.9. And this multiplies out to be 4.5, so 4.5 plus 1.4 equals 5.9. And that actually does, because watch, this 0.4 in the tenths place and this 0.5 in the tenths place makes 0.9 in the tenths place, or a 9 in the tenths place, I should say. And this 1 in the ones place and 4 in the ones place makes a 5 in the ones place, and that's true. Okay, so there you have it. Now what I was going to say is your little potential trick here is to take your, and I'll do this in pink just down here. This is a little aside just as a thing you could do. You could say 1.5x plus 1.4 equals 5.9. This is a trick that we learned a long time ago, which is to say, what if I wanted to make these all be whole numbers? Okay, well then how many places would they have to move over? We would just have to move over one here to make a whole number, and just one here, and just one here. So that's multiplying by 10 would do that. So let me say if you just did like 10 parentheses, everything that's there, equals 10 parentheses, everything that's there. And what that would do when you distribute that 10 through is it would turn into the whole number 15x plus the whole number 14 equals the whole number 59. And then you could be solving this problem if you prefer to have whole numbers. Okay, so you can go up here up top and you can say, I want to clear these decimals out and make them into whole numbers because I like whole number problems better. That's fine. You can do that. You don't really need to, though. You can hopefully work with decimals, and this is kind of an extra bit of it. And you do need to show this. You can't just take this and rewrite this. You need to show what you're doing there. Okay. But anyway, that's the thing you could do, and I'm going to get it out of there just because it's not what we actually did. So we won't leave there. Won't leave that there at the end. Okay, but that's something you could do if you wanted to approach it slightly differently. One more problem. Okay, same thing here. Maybe I will do this on this one, just what I just talked about, just because, why not? Just to show it to you, okay? 10 parentheses 1.1x minus 2.9, close parentheses, oops, equals 10 parentheses 0.4, close parentheses. Okay, you could approach it this way, or you could, just do it as a regular decimal problem. That's fine too. Okay, so what do we get? 10 times 1.1x is 11x, minus 2.9 times 10 is 29, equals 10 times 0.4 is 4. And now we say, okay, let's add 29 to both sides, so 11x minus 29 plus 29 equals 4 plus 29. And these are inverse operations that cancel out, and you get 11x equals 33. So 11x divided by 11 equals 33 divided by 11, or x equals 3. And we can do a proof on that. Of course, you're not going to do a proof on this equation, because if you messed up at all in here, then this number might work for this equation, but doesn't work for the original one, right? So you absolutely must go back to the original equation when you're doing a proof. You have to do that. Okay, so let's write proof. 1.1 x minus 2.9 equals 0.4. And then we have 1.1 times 3, because that's the value that we found for x, minus 2.9 equals 0.4. 1.1 times 3 is 3.3, minus 2.9 equals 0.4. And of course, you should be checking this math to be sure that it works out. If you can do that in your head, that's fine, but don't assume that it equals 0.4. You know that if we were doing it right, you would get 0.4 on the left-hand side. Do the work to check it if you need to. 3.3 minus 2.9. We're taking away more than we've got here. So we've got to say, okay, I'm going to borrow from the 3 and make it a 2. Now it's 13. 13 minus 9 is 4. Decimal comes straight down. And 2 minus 2 is 0. So therefore, 0.4 equals 0.4. Okay? I'm doing my math right in the middle like this because I don't have extra paper on the side that you could see. So you should be doing it out of the way of your work. Anyway, there you go.